morning, everyone. It's Dex here from A2K. And thanks for joining us for today's webinar, Just What is ReCap Pro that comes with the AEC Collection. Technical consultant Chad Smith will be presenting for us today. So before we start, we'll just go through about A2K. We're all about fostering innovation through consulting and training. A2K Technologies plays a vital role in open infrastructure, building, mining, construction, architecture, and manufacturing industries reach their full potential by delivering complete technology solutions and support services, such as education and consulting. We work with visionaries to shape the future of design, and in turn enable them through innovation to minimize risks, improve productivity, and achieve excellence. A2K Technologies is considered the business partner of choice and trusted advisor by vendors and clients. We partner with major software and hardware vendors to meet their clients' technology needs. We strive to exceed client expectations by pinpointing their challenges and delivering solutions through experience and innovation. We work with clients and companies of any size nationally and abroad. Over to you, Chad.
Thanks, Dexter. Okay, good morning or good afternoon to everybody. Thank you for joining this session on just understanding, I guess, what ReCap is that is included with the AEC Collection. Despite being part of the collection, ReCap is still one of those tools that not everybody has used. You may not even have received or used scan data or point cloud information in the past. So this session is just about demystifying a little bit about the history and about how we use this data that incorporates ReCap as part of a design solution workflow, I guess you could put it. As Dexter said, my name's Chad Smith. I am a consulting technical lead at A2K. I've been working in the general AEC industry across architecture and construction for just over 20 years, having worked formerly for design and construct companies myself. So before we get into just what ReCap is, let's just touch on a little bit of the history about why we have such a tool and about some of the data capturing requirements that the industry has available to us, because I do understand that maybe not everybody on the session today has that background or that history with this knowledge. So historically, it's been difficult to capture as-built information. There has historically been a lack of options for capturing it, and that can in turn mean a lack of missing information when you do need to ultimately utilize it in a design process. So we're obviously talking about things like as-built for maybe a renovated project, maybe surrounding information that you need to do the design in and around as well. So having a lack of information for these newer works that you then need to do could also mean that you might encounter design-related errors due to having inaccurate or potentially incomplete records of those existing conditions. So regardless of what stage throughout the project you are, having a lack of information can lead to problems during the design. But it can also be a problem whilst moving through that construction process as well. So having some as-built information at varying stages of the construction can also be useful for comparing that against the design intent. So these are certainly challenges that project members can and will likely face on many projects now and into the future. So we're probably well aware of devices such as what we can see on the screen at the moment. All right, these are typically old school hand measuring devices, and they're great for doing small measurements and capturing small spaces. But even though they have improved in quality over the years, compared to newer technologies, they are still very much a manual and potentially inaccurate process. So they're not really great at capturing data at scale, that is, huge spaces with many different data points that you can then utilize as part of the design process. So fortunately, in the current world, we can utilize more detailed, more granular information that typically comes in the form of scan data. And we can see that on the screen at the moment by way of the black points that we can see that are off shifted to the left. And this scan data has an infinitely more amount of data contained within it, typically sub-millimeter with the higher quality scanners. And we can more easily utilize this information rather than relying on hand measurements. And not to mention, with scan data, we're capturing the entire environment, or as much as we can potentially see. So therefore, when we do take this scan data, this as-built information, back into the office, we're not having to potentially go back out on site to capture any missing points, because all of this data is contained within the scan in the first instance. Now, over the last, let's say, past decade, maybe even longer, this technology has been evolving. It's been getting better, high quality, and also it's also getting cheaper. So over on the left-hand side is, I guess, what you would consider to be a fairly high quality top-end scanner for capturing this information that we will subsequently use downstream inside of Revit. This is predominantly for surveyors to use. They're well versed in how to use this, but even though that these high-end scanners are still quite expensive, those prices are coming down. And it's not only just the price that's coming down, but it's also the physical size and the portability of these devices. Now, obviously, when we get smaller with technology and cheaper, it's usually at the sacrifice of quality as well. So certainly the example in the middle, which is a handheld scanner, something that's actually fairly new within the last year or two. It's not quite as high quality in what it captures, but you have to weigh up what the intent is for how you're utilizing the data that's captured to determine, I guess, which devices you use or maybe have somebody else use to capture the data in the first instance. And as these devices start getting smaller and cheaper, we can also see them starting to creep into consumer devices, probably most notably the iPhone, which actually has a similar LiDAR sensor built into it, which they can use for things like face tracking with the face unlocked. It's another one on the other side of the phone, and also for using these consumer devices for augmented reality reasons. And this is typically now being done with the use of this laser scanning technology. So who knows, as the technology evolves, we probably get to a point in time in the future whereby even our mobile phones will be able to capture it at a good level of detail as what these handheld and these more expensive devices do now. And this technology is certainly becoming automated. So with advances in robotics, such as the Boston Dynamics Spot Mini that we can see on the screen at the moment, through to self-driving cars that we know are going to be coming in the next decade or so, and even drones, this reality capturing technology is slowly becoming prevalent in both our personal and our work lives. Now, call it far-fetched, but technologies in this space also appear to be converging. So just imagine for a moment, you're starting a new, let's say, redevelopment of a project, and you require some starting as-built data. Imagine for a moment that your self-driving vehicle leaves your office while you remain in the office. Upon the self-driving vehicle arriving on site, maybe a drone takes off from the top of the vehicle and performs an aerial survey, and maybe out of the back of the vehicle, something like a Spot Mini with a scanner exits the vehicle and does a ground scan, and possibly inside a building if it can get inside it as well. And once all of this data capturing is done by the drone and the terrestrial vehicle, the data is then transmitted by way of mobile 5G connectivity back to your office. All of these are real technologies right now. The question is just how much they converge moving forward. So as we can see, Digitizing the real world is big business now, and it's only going to get bigger into the future. So hence why we need to understand how we can capture and utilize this data as part of our design and construct process. So even if you're not the one responsible for capturing the data in the first place, you're most certainly likely to receive it in the future. And this is where ReCap comes into the picture. With today's hardware that is capturing the data, it can still be a little clunky to use it efficiently in the design authoring products. So we first need to prepare the data before we even reach the design authoring tools. And while ReCap itself is an authoring tool in that it outputs processed scan data, ReCap in itself is not actually a modeling tool. ReCap and your AEC Collection design authoring software, whether that be Revit, maybe Civil 3D, etc., actually go hand in hand when working with this as-built data. So on the screen at the moment are just some examples of some of the design authoring tools inside the AEC Collection, that is Civil 3D, Revit, InfraWorks, AutoCAD and its verticals, and also Navisworks can all use scan data that has been processed and exported by ReCap. Now, when it comes to ReCap, even though we're talking about ReCap Pro, which is included in the AEC Collection, there is technically a free version of ReCap, which is typically downloaded as a trial from the Autodesk website, but then falls back into a free, almost viewer for scan data. So I just wanted to make this clear going into this, that if you've downloaded it from the Autodesk website and you haven't licensed it, haven't paid for it, you're essentially using the free version. And this really just gives some basic viewing and editing capabilities of the scan data, and also some capability to export the data so that we can subsequently use it in our design authoring tools. When I do say it's limited, I really do mean it's limited in what we can do. The ReCap Pro that comes with the AEC Collection is certainly more feature-rich. ReCap Pro not only has the same viewing and exporting capabilities as the free version, but it also gives us the ability to import and go through what we call a registration process of the scans before we then export it for use in those design authoring tools. It has better viewing tools. It also has things like advanced measuring and marking up and so forth. And it also has the ability to break the scan data down into what we call scan regions. In addition to the ReCap Pro features for utilizing scan data, it also includes cloud features that covers ReCap Photo. So this is the photogrammetry aspect of ReCap, whereby if you capture numerous photos, we can use ReCap Photo to then generate a 3D scan file, sorry, it's a bad term to use, a 3D point cloud file that we can again use in our design authoring tools. And also it comes with some additional cloud features so that you can share the photographic information that comes from laser scanners up to a web service so that you can have non-ReCap users review that photographic information. Now, I'm going to touch on the use of laser scan data and the photogrammetry in a little bit of detail so that you can understand what the difference is, particularly if photogrammetry sounds like a bit of a foreign term at this stage. Now, I'm going to go through a couple of hands-on examples, but let's just start by going through a high-level overview of some realistic examples of what we can use ReCap for. For the most part, you're likely to use it with laser scanned data. This comes in the format of point cloud files, And just briefly, if you've never seen a point cloud file before, think of a file that is made up of millions and millions and millions of points. Each of those points have a color to it. And when we view all of these points together, it almost looks like a 3D scene. All right. Now, ReCap, we're going to go through basically how we can register it in the first place, and then how we can view it and edit some of the data that's captured within it. I'm going to use this example, which is a small church, to additionally show you the fact that we can publish it up to the cloud version of ReCap so that we can share it with other users and they can view the photographic information and then contribute some annotations to it. The second example is utilizing similar laser scanned information, again, so that we can clean this information up, but then we can put it into other authoring tools such as Revit. We can see in that image in the bottom left-hand corner that we have a Revit model with some augmented scan data, but it's not all the scan data that's included within that Revit model. You can quite clearly see that we've got our scans and we've got Revit modeled elements. So the question becomes, how do we use ReCap to differentiate the point or scan data so that we can break it down to separate the equipment out from the building? And when we do separate it out and we want to start doing some model coordination, maybe doing some clash management tasks, how do we subsequently utilize this information in other tools such as the Navisworks? The next example is doing something similar where we're using ReCap to break the scan data down into its smaller parts, but in this case, utilizing photogrammetry data, which is typically these days captured by way of drones with aerial surveys. And therefore, can we utilize that scan data for then generating contours, which we can bring into Revit, not to mention doing the modeling of the building and looking at maybe smaller and more detailed uses of it, such as this mailbox design that we can see in this top right-hand corner. And the last example, and I'm not going to show you an actual example of this, but just to explain, here is another simple but realistic example that I used personally about a decade ago. I live in Brisbane and I was back looking for to purchase a new home. And this one here was of significant interest to me. This, as you can see, is on a little bit of a sloping site, and due right is a perfect view of the Brisbane city. But obviously off to the right-hand side were other houses, and I couldn't quite tell if I could actually raise this house and would it actually give me good sight lines to the city as a view. So what I did when I went out on site, I took a DSLR camera with me. I took about a dozen or so photos, all from the street around the perimeter of the building, passed it through ReCap Pro, ReCap Photo that is, and generated a very rough point cloud. This point cloud, I could then bring into Revit, start getting measurements, working out maximum height limits and so forth, and determining at that feasibility level whether this was a house that was worth buying if I could raise it, maybe add an extra story on. So those 4 examples, just as an overview, should just give you a little bit of an idea as to some of the different ways that we could potentially utilize ReCap, either without going out to a design authoring tool like the one on the screen at the moment, or getting it prepared for use in a design authoring tool. So let's have a live look at some of these examples. I'm just going to close that down. Let's jump over to, let's start in ReCap. I'm going to come back to all of these. This one here. Okay, and I've got a folder here, and in this folder contains a number of scan files. Again, if you've never received or used a scan file, they do come in a variety of different file formats. And in this case here, the size of these scans, they're not massive, about 150 megs each, but you can start sort of mentally calculating up just how many megabytes or even gigabytes of data you may need to process, of which you don't always have to process all the files in one go. You can actually do smaller groups, maybe pick a zone within the building, because ultimately when we get this scan data registered and sent downstream, you're probably not going to utilize all the scan data in one go inside of Revit or Civil 3D and so forth. So with our scan data here, inside of ReCap Pro, we would start a new project. And instantly we can see here that we can either import point cloud data, that is my scan files, or if we've got photos for a photogrammetry project, we can import the photos and convert them to 3D. Regardless of which process we go through, it's still going to be a fairly process and processor intensive task, which may require many minutes, maybe even sometimes a few hours for it to ultimately finish processing. Now, the beginning of this process with using the import from a cloud, typically, I'm just going to call this webinar, requires the creation of a new project, which I'm going to put this. Let's see here. What I'll do is just capture the path of that. All right, I'm going to put that into that folder where that scan data is and proceed. It then requires us to select our scan data, which we can, if need be, we can go ahead and typically just drop this in. We can set a number of initial scan settings. And basically what this is doing across a number of these settings before we import this data is it's asking you the questions of, based on the quality of the scan data, do you want to limit the amount of points within those scans for the ultimate registration and editing process a little bit later downstream? So for example, if I've got a scan that has points that might be being captured 50 meters away from the scanner, well, 50 meters away is not entirely all that accurate, as opposed to maybe points that are only 1 meter away from the scanner. So therefore, we can do things like maybe capturing the range of which points we want to use when we register this together. So just as one example. Now, once we've got those settings set, we can go ahead and import the files. This will go through an initial importation process, and this is where this processing time now starts kicking in. And once this has been imported, we can typically then use the auto register scans button in the bottom right hand corner, and based on the, I guess let's call it feature recognition of ReCap, it'll work out with a fair degree of accuracy which of these scan files overlap with other scan files, and then merge them all together into a final 5-scan scene. Now, this automated or this auto register process isn't always perfect. So therefore, it does give us some options for doing manual registrations, and that ultimately requires some more work to pick, that is manually and visually pick common points between these scans, so that you can tell ReCap which scans to register next to other scans. Now, this is where I'm going to just stop this importation process, because as I said, it is an intensive step. I'm going to go back to the home page. So let's go ahead and suspend that. And let's open up one that I've already done the processing on. I'm going to open up this St. Mark's. All right. So again, for those people that have never actually seen what a point cloud or a scan file looks like, this is it. You can see it contains, if I zoom in, many millions and millions of points, which when we zoom out, kind of makes it look like a 3D scene. But we can also see that this scan data isn't necessarily perfect. No, sorry, it's perfect in that the data is accurate, but it's a little messy. Okay, we can see that we've got a range of points around the outside that we possibly don't want. It's up to you to decide whether you want to keep them or not. But this is when we start using some of the editing tools within ReCap to start cleaning it up. For the most part, this is going to be done by using our selection tools. I'm going to use the fence selection here to do a fence selection around some of these points, like so. And I now have the option of whether I would like to clip them, that is, temporarily remove them, or would I instead like to delete the points. Now, when we delete the points, they will eventually be removed from this project file when we do hit the save button, as opposed to if we were to clip them, which would otherwise maintain the points, and therefore we can bring them back into visibility at a later stage if we want. But it is otherwise, oops, just a process of cleaning up. So I might just do a few more here. Just delete that out. Maybe it's something vertical as well. So we can see here, we can orientate around and we can be as accurate or as rough as we need. So for example, if there is a little bit of a peak up here over this window that we would like to keep, we can do it a little bit more accurately. Otherwise, it's the case of going around, double clicking to finish. Oops, and there we go. And again, I can delete or clip that information out. Now, this scene here, when we use our Project Explorer down in the bottom right-hand corner, this is going to show me that I have the individual scans, okay? And when I click those scans, you can see there, we can start navigating around the scene, like so, right? That can be used as a quick way to get within the project, from which I can then start panning and orbiting around like so. And again, if you've not used this data, you can start seeing the value of why we might use a scan file rather than maybe just tape or laser pointer measuring devices, because it doesn't really matter which angle we're viewing this from, we're maintaining as much data as we possibly can so that we don't have to go back out on site and take future measurements. Speaking of measurements, ReCap does have its own measurement and annotation tools. So we can see here when we use something like our distance tool, so long as we are accurately picking points in our scene, like so, and if I've done that correctly, and I think that's close enough, we can start seeing, we can take measurements in 3D. So even if I'm not utilizing the scan file in a design authoring tool, we can certainly utilize the measurement tools and notation tools inside of ReCap to capture information. So if that's a dishwasher, we might say remove dishwasher, put some additional notes in here and finish that off. And when we save this ReCap project file, this is additional information that has been captured that other ReCap users can now view when they too open up this ReCap file. In terms of continuing on with that viewing, this is obviously showing our points with their actual scan colors. So we're getting a nice sort of colorized scene. Over here on one of our menu items towards the left, we have some visualization tools, of which probably one of the more useful ones is this color mode, which, as I said, is showing the RGB colors of those points. But one of the other great visualization tools is the elevation. Now, if we were to go ahead and just set, let's see here. That should be right. Oops, sorry, I'm still within my annotation tool. Why is that? There we go. That's removed. Okay, cool. Okay, so with these, I might actually, let's see here. Let's go new gradient. Okay, and we might set a range where we'll use maybe a minimum and a maximum, like so. You can see there we can apply a color gradient over the top of the points so that we can get a better visual representation of the peaks and troughs. This might be all too obvious with a building with just the RGB visualization that we had set before, but if this was a survey of a block of land, okay, the terrain, utilizing something like this elevation color mode can give us a better representation of the peaks and troughs over the top of, let's say, a topo surface. I'm going to change that back to RGB. Now, as part of this example here, let's say we've got this prepped, we've added a couple of notes in, but we would like to share this with a non-ReCap user and share it to somebody by way of a web interface. Up here on the home button, we do have a publish tool. This will publish it up to ReCap in the cloud, and it will also generate a shareable link that you can email to somebody. And then if I come over to a pre-loaded web page, that user with their link in the email will be able to go directly into the project that you've shared with them, which I've got open here in another tab. And this now gives them a web interface for viewing the photographic information that comes with the scan data. I want to make it clear, this is not the point cloud information that we're utilizing. It is the photos that come with the scans. Because scans can be many gigabytes in file size, that's obviously a lot of data to put up, but utilizing these 360 photos, you can see here that we can navigate in a very similar fashion to what I showed you a moment ago over inside of ReCap. And it also includes similar tools so that we can add measurements and potentially notes to share written and measured information between a design team member and a third party who doesn't typically use ReCap or an authoring tool. Okay, so let me go back to ReCap. I'm going to jump back out of this and let's open up, it's disappeared. Oops, sorry, wrong button. Let's try that again. We'll go through here. Let's don't save that. Let's open up this one. Okay, so if we want to talk about a workflow from ReCap into something else like Revit, okay, here we've got a building that we may need to remodel. Now, this here is an extremely complex scene. It's got plenty of equipment that's distributed throughout. It's going to get in the way, of which most of that equipment we're not really interested in for the purpose of remodeling the building itself. All right. By the way, this project here that I have open is the default sample one that comes ReCap. So you can certainly use this for doing a little bit of testing. Now, I've already shown you how we can use some of these selection tools like the fence tool, whereby we can utilize it to draw a boundary, let's say around something like some equipment, like so. But the downside with utilizing the fence selection tool in this case is as we navigate around, we can see that it's also picking up some points, such as on the floor, possibly even the wall in the background here, which we want to maintain as reference for when we do reach the modeling stage. So I want to call out probably a fairly underutilized selection tool, and that is the plane selection. This allows us to pick points on any given plane. Now, this tool requires us to pick 3 or more points on a surface. And for the last point that I select, I'm going to double click it. And what you can see is that it's picked a very thin slice of points throughout the scene. I do have a plane depth tool down the bottom here where I can decrease the thickness of this plane depending on how many points or how well it's picking up those points. But the point here, not to use a pun, is that we want to start isolating fairly flat or typically flat architectural-like surfaces so that we can separate them from other elements such as the equipment. Now, it's one thing to be able to select this information, but it's another thing to maintain that selection so that we can prepare this as part of an export. Down in the bottom right-hand corner, we have what we call scan regions. And before I dive into this, I will provide the caveat that scan regions are notoriously difficult to use with the more scan regions you add and the more points we add to those scan regions. So the caveat is the speed of ReCap will be maintained as you start using the scan regions, but the more and more you utilize this feature, historically ReCap starts slowing down quite a bit. So I just want to put that caveat out there. But otherwise, with our points selected, we can now add them to a region. So I'm going to call this walls and floors. Okay. So what this has done, it's given me essentially a layer within my ReCap file, and that layer has a visibility button, and I can actually go ahead now and turn those points off. Let me do a little bit more. I'll go through, let me capture a few more points, maybe the wall here. If I hold down the Shift key, I can actually then start selecting other surfaces like so. And you'll notice when I pick that last wall, notice there's a slice that ran all the way through this saw table, and I think that's a bench there and so forth. I'm not going to be too concerned about that because I'm doing a fairly rough estimation here at the moment, and I can always come back and make refinements. But otherwise, I'm going to reuse that same region that I generated and add those points to that scan region. So we now start separating out all the unassigned points from the new points that I've just added onto a scan region. So hopefully you can see now that we can start breaking this otherwise complex scene down into more simplified groupings. And this is key to now bringing this data into our design authoring tools. So with this scan region now visible and the equipment turned off, up here on the home button, we now have the ability to export just these visible points out to what we call a scan file. So I'm going to come down here and you can see that I've got an RCS file format. That is an Autodesk ReCap scan file. Autodesk design authoring tools like Revit, AutoCAD, et cetera, typically utilize RCS files. You can link a point cloud directly into those design authoring tools, but in the back end, the design authoring tool is going to do some processing on that file and convert it into an RCS file. If we do this process inside of ReCap, we've got the ability to now clean the scene up, delete things out we don't need, and also using these scan regions before we export out. Now, I've already done this process. We can see, let me go back to that tech shop. And you can see here, I've already got a number of RCS files broken down into things like the floor, the walls and columns, the equipment on its own, and also the ceilings and the lights. So let me now jump over into Revit. Okay, so here we go. Here's my Revit file. And I just want to show you, when I go into the Insert, Manage Links, over onto the Point Clouds tab, we can see those same 4 RCS files that have been loaded in. And within this particular view, all of those RCS files have been hidden except for the equipment. Now, when I modeled this up in the first instance, I would have gone ahead and maybe turned on some of these point clouds on their own just to improve the modeling process. As I've said a couple of times now, we use ReCap to prepare the scan data before bringing it into the design authoring tool. We prepare it in such a way that makes sense for easing the modeling process. So in this case here, if I turn on the floors, the walls, and the columns, you can see there, let me just get this wall. I'm just going to temporarily hide it out. There we go. You can see there, just as I orbit around to the right-hand side, I have just that point cloud data. And what it means is when I'm working in other views, such as a plan view, okay, I'll see those points, and that'll then give me the references for the walls so that I can go ahead and model my wall elements in. This is not a straightforward process. It is a manual process. I will point out that there are third-party Revit add-on tools from typically surveying or scan vendors that provide add-ins for Revit, AutoCAD, and so forth that can help automate this process. However, if you're not using those third-party add-ins, then it is a case of manually modeling those elements over the top of the scan data. Now, we go back to the 3D. Not that one there. Let's go to this one. All right. So when I first opened this file up, I had the equipment turned on and all other model scan data turned off. Now, from a Revit perspective, this is now still providing me existing context of the equipment in my now modeled as built building. But we know that we then can have further downstream workflows and checks and implications between the scan data and the model. For example, if we have scan data that we've got, maybe from another consultant, and we've got our modeled architectural building here, we can take this information further downstream into tools like Navisworks. Here we can see I've got my tech shop Revit file plus that same RCS file that was exported from ReCap. And I don't know what it's now doing. It's, let's see if this bounces back. I do have quite a number of applications open, as we can see down the bottom here. Okay, I'll just deselect that. There we go. All right, so we've got scan data with our Revit model. And this still continues to provide value as part of that design and construct workflow. Because we know with our existing equipment, if we're now doing modeled renovations, we want to know, does any of this renovated work have any clashes or any other design implications against our existing equipment? So in this case here, I've set up a couple of clash detective tasks whereby I might want to do a clash test of the equipment against the structure, or maybe of the equipment against the services. And we can see here, as results of the equipment and services, that I've got my scan data for what is I think it's a dust extraction box up on the ceiling, and it's actually finding a clash against an existing or proposed location of a light. Now, how we set this clash up is important. And when I go back to the clash settings, quickly looking at the RCS in particular, at the bottom of its settings, we're noting that we're checking against points rather than surfaces, which is the typical default option. And this is important because we need to specify that this file has points, whereas the Revit file is clashing with surfaces. And lastly, when we do this test, we've got to provide a larger than usual tolerance, because the gaps between the points could very well be 5 mils apart. They might be 10 mils apart. So therefore, we need to provide a tolerance so that we can pick up the gaps between the points that are within those scan files. Okay, so let's move away from this one. Let's close that out. Let's come back to ReCap again. I'll go back to the home, and I'm just going to open up Let's see here. I have to go back. Don't save that. Let's have a look at this A2K office, and we'll get this one opened. Okay, now just while this is opening, it's just going to take a little moment. I'm going to come back over to the data set that was used, in which case was photos that was used through ReCap Photo to generate this 3D scene. Photogrammetry is difficult in that you need to somewhat understand how to capture the photos so that they can be processed accordingly to get such an output. Now, here I've got a number of different photo data sets that I could have used. If I have a look at something like this scanned data set, and I might just increase the thumbnail size here, you can see there, this was captured by a drone. This is actually the Brisbane A2K office, and a number of photos were captured as a multi-pass flyby over the top of the building. Okay, and we've got somewhere in the order of 86 photos for this particular scene. They were passed through ReCap Photo to then generate my 3D scene, that we can see here. Okay, it's not perfect. You know, the likes of photogrammetry, you know, they're not necessarily millimeter perfect, but in this case, it's good enough. It's good enough that I can then use my selection tools and my scan regions over here to do the same thing as what I showed you with the tech shop, whereby I can start isolating the building away from any outside or terrain or foliage information. This gives me the benefit of putting the building into Revit so that I can model the building, and putting the terrain points into something like Civil 3D to generate some contours. So let me jump over to Civil 3D, whereby I have already pre-attached my point cloud files. All right, and just before I generate these contours, just note that this is not a perfectly flat topo surface that we can see here. It's got a couple of stairs and a ramp out the front. It's got some rubbish bins down the back there, but it's good enough. With this point cloud selected, we can create a surface from the point cloud using what we call a style. And a style is a definition that says, are we generating contours, maybe versus the surface and other kind of topography types of elements, in which case I've generated a style that creates only contours at 0.25 of a meter increments. I move on to the next step. I'm just going to make a change here. I'm going to set this to 1, and that'll reduce the number of points that I'm going to use. And then I'm going to create the surface. This is probably going to take 5 or 10 seconds for this size of point cloud. But what we're generating is some contoured information, which if I was to actually delete out the point cloud, we can see there that we have a reasonably flat and reasonably accurate surface. Notice it doesn't have any of those high peaks where those stairs and the ramp were, and where the refuse bins were down the back. And that is because as part of that creation process, I did adjust one of those settings to reduce the number of points that we'd use, and therefore that gives me a simplified version of the topo surface or the contours, which I can now save as and bring that into Revit for our typical topo surface generation process. In terms of bringing that that photogrammetry of the building into Revit, let me jump over to this file here. Similar to that text shop example, we're going to import in our point cloud. This is a locked view. Just let me unlock this. Okay, we're going to insert the point cloud. Okay, it looks messy. It's not, again, it's not perfect, but that is enough so that I can then use my Revit modeling tools to do my modeling process, which if I open up this other view here, sorry, I don't know why that point cloud is on. Let me just go ahead. I thought I had those point clouds turned off. Okay, sorry, looks like something had changed leading up to the webinar. These point clouds currently turned off, but this would otherwise give me a fairly clean looking Revit model, which is probably going to be perfect for doing some maybe early feasibility modeling. Maybe it was a neighboring building that I needed to capture in some level of detail for the actual building that I might be designing next door, and so on. But that photogrammetry process doesn't necessarily have to be relegated to an entire site like this. Maybe I needed to pick off just a very small part of the site to do a little bit more detailed modeling. So the last example that I want to show you here is just a smaller photogrammetry project. I'll open up this one. It'll be this one here. Okay, and again, just while that's loading up, let's have a look at what the photos look like for this scene in here. It's going to be the images. Okay, so this was specifically an exercise in what if we wanted to pick a small part of the project to maybe do like a redesign for a letterbox location out the front of our office. Okay, this has 38 odd photos that were taken at ground level, but taken at various heights at the ground level. So holding the camera up high, bringing it down to about head height, and then maybe going down to around leg height to capture 3 different heights. Again, that was passed through the photogrammetry, that is ReCap photo, to generate a fairly small, but in this case, reasonably accurate scene. Okay, now in this case, as part of the cleaning up process, what I've done is I've removed out this end block wall that was at the end here, and I've also removed out the handrails that were over the top of this block wall here. By removing those points from this scene, again, I can come up to the home, over to the export, and export this out to an RCS file. When I come over inside of Revit, we can link in the scan file, and I can now start doing some modeling over the top. And if I actually go to the 3D view so that I can navigate around, there we go. We can see there, that's not a locked view. Okay. We can see there that we've now got a completely different handrail and letterbox wall that's sitting over the top of my point clouds. And we can actually now utilize the scan data, similar to what I had open just a moment ago, the scan data with our modeled information, putting that all on a sheet, maybe with a floor plan, and we've now got some fairly presentable information that we can print out to a PDF and give that to the client and say, does that actually look like what you expected?